everything we've done up till now is fundamental counting principle, and something important was happening. And what's important was the order mattered in which you were putting things. So when we talked about, like, you have to sit people in a row, well, it mattered if McGregor was in the first spot or the third spot, because when he switched spots, that changed the whole arrangement. That's not always the case. Order doesn't always matter. And when order doesn't matter, that's when we talk about combinations. Okay? Combinations can be represented using this right here. That would be NCR, and you will be given that on a formula sheet. If you look at your formula sheet that you have, it is there. It's on the right-hand side. You'll see NCR. It doesn't tell you what those things mean. Okay? So we need to understand what each one of those letters is talking about. N is the number of things that you are selecting from. So it's the total number of people, the total number of objects, it's the total number of things. R is the number that you're actually picking. So for instance, if I wanted to pick 3 people out of a group of 10, 10 would be the total number, and 3 would be the number I'm actually picking. C stands for combination. So C is combination, it's an order, does not matter. It's the biggest thing. Order does not matter. You have to have that understood. Combinations, order doesn't matter. An example of how that happens. If you read this one right here, example 1. It says in a class of 10 students, Mr. Kennedy needs to choose 4 to help clean up his classroom. Does the order Mr. Kennedy chooses the students matter? Why or why not? And let's think about it. I've got 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got you 10 right here. I need 4 people to clean up after the class. I pick McGregor, Conwin, Brandon, Katie. Is that any different than if I had picked Caden, Bronwyn, McGregor, then Brandon?
Yes.
It's no different. All 4 still have to clean the classroom. Doesn't matter what order I picked them in. That's a situation where order does not matter. You don't care if you were the first one selected or the 4th one selected. You're still just part of the group. Think of it picking a basketball team. If your goal is to make the basketball team, you don't care if you were the first person or the 10th person who made that team. You just wanted to be one of the ones selected. Order didn't matter. So in this situation, does the order matter? No. And the reason it doesn't matter is because all the people are still doing the same thing no matter where they were picked. So that's how I'm going to describe it. You use your own words. All people are doing the same thing no matter when they were picked.
Basketball, like in the NBA, does it matter?
Yeah, that stuff would kind of like technically matter.
Straight draft picks.
Yeah, and they make money depending on when they're picked and stuff like that too, right? Like someone picked first, they'll get more money right away than someone picked last. So that like the order would matter, but something where you're just all getting the same job, it'll be very clear to you. It won't be ambiguous cases like that. It'll be like these 3 people are doing the cleanup. I don't care if I'm first, second, or third to be a cleanup. I don't want to be picked up. So it doesn't matter which order you're picking. How many different groups could I pick then out of that group of 10? And what I'm going to show you is what we used to do. So what we used to say was, I need 4 people. 1, 2, 3, 4. And I'd say there's 4 people I need picked. The number of people I could pick is 10 here, 9 here, 8 here, 7 here. The reason that this does not work is because when you place them like that, you're saying it matters if you were the first person chosen. You're giving responsibility to that first spot. You're saying 10 people could go here, and it matters that 10 people could go here. So this method will no longer work. Instead, you're going to use the combination formula. Okay? And that thing says n N is the total number that you could be selecting from. So I have a group of 10 students I'm selecting from. I'm going to choose R amount of them, 4. So that's 10 choosing 4 of them. R is the number that you're actually choosing. So if there was 10 total I could choose from, I chose 4 of them. The bigger number will always be the first number. This is a button in your calculator. So depending on your calculator depends how you do it. What I do is type 10 first. So I would turn my calculator on, I would go 10, 1, 0, and then I would find my button for combinations. If you click math, and then over 3 times to be under PRB, you'll see it's the third option, NCR. And when I hit enter on that, my calculator looks like this. That says 10C. Like that's what pops up on my calculator right now. Oh, sorry, NCR. If you have a newer calculator, I think it'll actually put the number in where N is. So if you have a newer calculator, what you should see on your screen right now is 10C. And it's letting you fill in the spot for R. Okay? So 2 different calculators, they look different. It's the same idea. So if I'm using an older calculator, I'm currently at 10 NCR, and then I want to choose 4. So I go 10 NCR 4, and if I hit enter, that tells me that there's 210 ways that I can select 4 students out of my group of 10. So for instance, if we're trying to think of all those combinations, because you might think that's a lot, I could pick Taylor, Jaden, Hunter, and Mac. Then I could pick Taylor, Jaden, Hunter, and Bronwyn. Then I could pick Taylor, Jaden, Hunter, and Brandon. And I could go all the way through the group of 10, and then I could go, I'm going to pick Caden, Hunter, McGregor, Bronwyn. And I'm going to go Jaden, Hunter, McGregor, Brandon. And you notice how many times you could cycle through. So that might seem like a large number, but that's the realistic side of things, is it's a lot. And it's a lot of combinations you could do, because you just change one person every time. All right, NCR, combinations, actually has a formula. It's this right here. It's on your formula sheet, so you'll always have it. It's the mathematical way of knowing what it's doing. So when you're doing NCR, what you're really doing is you're doing n factorial divided by n minus r factorial times r factorial. So if we were to do that with the last question, we said in the last question that n equaled 10 and r equaled 4. That's the number I can choose from. That's the number I'm actually choosing out of that group. So I put that in my formula. That means I have 10 factorial divided by n minus r in brackets, so 10 minus 4 in brackets, factorial, and then 4 factorial. So that's how that formula would look if I was actually plugging the numbers into the formula. If I was to simplify that, 10 minus 4 is just 6. So this actually equals 10 factorial divided by 6 factorial, 4 factorial. That's how the formula works. You do sometimes need to be able to write it in that form. So instead of saying 210 ways, your answers might all look like this in factorials. So you would be able to take your information, put it in the formula, and then just write it out. So you do need to be able to do both ways. If you ever write it in factorial notation, you got to do it that way. And that will pop up on, I think, a quiz or your practice booklet. It says write it as a factorial. It means you have to turn it into that method. Just so you understand what these numbers mean. 10 factorial is the way that I could arrange the 10 students. Then you're dividing out the fact that the order doesn't matter. This is dividing 6 factorial, that's the order of kids I didn't choose, and then you're dividing out the order of the 4 kids I did choose. So that's how that's actually working, is you're dividing out the fact that order does not matter. And that's just how it works. So So if you're wondering, like, why is it 64, like, why is that formula what it is, you're dividing out the fact that order doesn't matter, not only in the group you chose, but in the group that you didn't choose, it matters as well. All right, the value of n is still the number of things that you can choose from, and r is still the number of things actually being selected or arranged. The other thing you might see is instead of writing it as NCR, you might see it written like this, where it's N over R, and there's nothing separating them. These mean the exact same thing. So instead of writing NCR, they could just write 10 over 4 in brackets. And there would be no division symbol or anything. When you see that, that means combination. And that's also on your formula sheet. I want to confirm that. Yeah, it even tells you that NCR equals that. That's on your formula sheet. So if you ever see something crazy like that, look at your formula sheet and be like, oh yeah, they're just saying combination. This is N, this is R. That's all they're saying. All right. Combinations, there's not a lot of examples for them. So because it's a pretty simple concept, you punch in your calculator, good to go. Example 2. H.J. Cody is picking their grad committee from a group of 5 boys and 6 girls. If the committee has to have 5 people on it, how many different committees could be formed? How many students total do you have? You have 11. Does the question say anything about it has to be boys, it has to be girls at this point? Nothing. So you're just worried about, here's my 11 people, I need 5 of them to represent the grad committee. Does it matter if you were the first person on the grad committee, the 3rd person, or the 5th person? Is there a difference? No. All 5 have equal rights, equal roles, equal responsibilities. They're all the same. So order does not matter. That's the first thing I always ask myself. Order doesn't matter. And as soon as you recognize that order doesn't matter, you know you're dealing with combination. Order doesn't matter. I'm doing a combination. I'm going to use the formula NCR. N is the number of students I can choose from. How many can I choose from? 11. I'm going to choose how many of them? 5. That's what R equals. So in your calculator, you're going to put in 11, and then you're going to use your button, and you're going to select 5 of them, and you get 462 ways you could select that committee of 5. Pretty simple, right? Alright, these get more complex when they start adding in restrictions. Right? Just like the fundamental counting principle got more complex, so does this stuff. So question B now says, what if the committee must have exactly 3 girls on it? So now, you're not selecting from all 11 students. You're selecting 3 of them from the girls. How many from the boys? That means there's 2 boys. There had to be 5 total. So now you know there's 3 girls and there's 2 boys. And you got to figure out how many ways you could do that. Does it matter if you were the first girl chosen out of the 3? No. Doesn't matter if it's the second girl. No, for this, it doesn't matter. So order doesn't matter. I always remind myself that. It might seem tedious, but when these questions start getting all mixed together, your first thing is going to be, does it matter? In this case, it doesn't matter. So let's focus on the girls first. How many ways could I choose the 3 girls to be on that committee? If the order doesn't matter how I'm selecting. My N would now be 6, because there's 6 girls to choose from. And I'm going to be selecting 6C3. That's me selecting the girls for the committee. How many ways could I select the boys for the committee? 5C2. There's 5 boys. I need to select 2 of them to be a part of this committee. It does not matter which order I pick. If I go Caden and McGregor, it's the same as I go McGregor and Caden. It's identical. Both are on the committee. Both have the same jobs. Now what you need to figure out is how to link these 2 things together. Should we be adding them, or should we be multiplying? The best way to know is ask yourself if they're affecting each other. So, if I choose 3 girls, does my overall committee group change depending on my selection of boys? So if I pick my 3 girls, and I'm like, all right, I'm going to go with Caitlin, Hannah, and Cammy. And then I choose my 2 boys, I'm like, it's going to be Quinn and McGregor. Is that committee now a different committee than if I had said same 3 girls, but it's Quinn and Ewan? Is the overall committee different when I change my boys selection? The answer is yes. Because there's 5, the committee is made up of 5 people. 3 of them are girls, 2 of them are boys. Depending on who I choose for each group, changes the entire committee. If they affect each other, you're multiplying. If they didn't affect each other, it's when you would add them. And I think we have an example of that coming. So in this situation, you're going to go 6, choose 3, times 5, choose 2. I don't know what that is. So 200 is definitely the right answer. Now, just for argument's sake, let's pretend I added them together. That would be 20 plus 10 for 30 different committees. And I already know that there's 462 possible committees out of that group. Does thinking that there's only 30 that has 3 boys and 2 girls seem realistic? That seems way too small. That's a tiny number out of that 462. So I'm probably thinking to myself, it's got to be a bigger number somehow. So I must have made a mistake. Yeah. That makes sense? If they affect the overall situation, multiply them. If they're separate situations which don't affect each other, you add them. All right, C. What if the committee must have at least 1 girl on it? This is where you're going to have situations that don't affect each other. So I'm going to show you one way to do it, and I'm going to show you a better way to do it. The first way, if I have at least 1 girl, that means I have 1 girl, or 2 girls, or 3 girls, or 4 girls, or 5 girls. Those are the 5 situations I could have, right? Those are all at least. So situation 1 would be only 1 girl made the committee. Situation 2 would be 2 girls made the committee. Situation 3 is 3 girls made the committee. And then 4 girls made the committee, and then 5 girls made the committee. Those are all at least 1 made the committee. Let's do just the first one. If 1 girl made the committee, I had 6 girls to choose from. I chose 1. Times, I had 5 boys to choose from. I chose 4. So there's only 1 girl, the other 4 got to be boys. You punch that in your calculator. I think it's a small number. 5, 4. It is 30 ways that 1 girl gets. If you did number 2, you'd be doing 6, choose 2, times 5, choose 3. You punch that in your calculator, and you get 5, choose 2, and then, 6, choose 2, and 5, choose 3. You get 150 ways. The 3-girl situation we already solved. That's 200 ways. We solved that in part B. 4 girls, go 6, choose 4. That's, I'm going to do it in calculator. choose 1. So that's 75 ways. And then if you chose all 5 girls, that'd be 6 choose 5. And you didn't select any boys, so you don't even need to worry about doing the boys. There's your 5 situations that could happen with at least one girl. You've got 30, 150, 200, 75, and 6. And you need some way to link all those together. This is a situation where you add your results. So, there's my committee with exactly 2 girls. If it changes, does that affect my committee that has exactly 1 girl? No, these are 2 completely different events. So they do not affect each other. So if I want to figure out the total number of ways, I would add them all up. So 30 plus 150 plus 75 plus 6. And I put that in my calculator. 30 plus 150 plus 200 plus 75 plus 6, which is 461 ways I could choose at least 1 girl. Now let me tell you, these questions get bigger, and now you have 52 cards and you're trying to select something out of it. Or you have 100 toys and you're trying to find exactly at least 2 of them or something. You're going to have to do a lot of these. And it's time consuming. And on a unit test or a diploma, which is timed event, you need to be able to do it quicker. To do it quicker, we consider the complement. What does complement mean? The opposite. So if I want at least 1 girl, what does that mean? It means I don't want 0 girls. That would be the opposite. The opposite would be if 0 girls made the committee. So what I'm going to do is I'm going to take the total number of situations, which we already solved, 462, and I'm going to subtract the situations that are 0 girls, and that would leave me with all the other possibilities, which would be 1 girl, 2 girls, 3 girls, 4 girls, 5 girls. Now I only have to do 1 calculation versus 5. So if I'm selecting 0 girls, how many boys did I select? 5. 5, C, 5. Yeah, what we don't want. This is all the possibilities. So all, and then subtract the complement, the opposite of what they want. Because that will leave you with what you did want. Total possibilities of what you are looking for. If you go 462 minus 5C5, your answer is 461, which is the exact same answer that we had over here when we did it the long way. Understanding complements and utilizing complements, very, very useful. Much faster. Especially as questions get bigger. Any questions? If I showed you that, what does 5C5 equal? All the boys, there's only one way you can do that. There's 5 boys, I needed all 5 on the committee, order didn't matter, that's only one possibility. So it's 462 minus 1 equals 461. 462 came from the first part, which told me all the different committees that were possible. It's important to recognize that.
You could do the same thing if there was like 6 boys, but you wanted 5 boys.
Yeah, so if there had been more boys, then I would have gone 462 minus 6 choose 5. And that is possible too, right? And then your answer would be a little bit different. But the fact that it was 5 choose 5, there's only one way to do that. All right. At least is the one situation we just saw. At most is another situation. When you see that, what you want to do is use the complement. That's what that page is telling you. The complement is the opposite situation. Example 3. In a group of 50 students, so the number's going to get bigger. Half are males, half are females. That's good to know. So it's 25 are males, 25 are females. Describe how to figure out the number of ways you could pick a group of 10 students with at least 2 girls. All right, one way I could do it is I could calculate, and I want us to describe it, not actually do it. So calculate if there were exactly 2 or 3 or 4 or 10 girls. So you can calculate all the situations, then add them up. That's a legitimate strategy. It would work. If you broke that down into 2, 3, 4, 5, 6, 7, 8, 9, 10, and calculated each one, added them together, that would definitely tell you the way that at least 2 girls were on them. Solution 2 would be to take the total number of possibilities and then subtract the complement. So if I took the total number of possibilities and I calculated that, I said, okay, there's 50, I need 10 of them. That's how many possibilities there are. It's going to be a big number. But I want to subtract out if there was no girls. Or 1 girl. That would leave you with 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you take the total, subtract out the opposite, you're left with what you wanted. Much easier. That requires 3 calculations. I have to calculate the total, calculate 0 girls, calculate 1 girl. Doing it this way, I got to do 2 girls, 3 girls, 4 girls, 5 girls, 6 girls, 7 girls, 8 girls, 9 girls, 10 girls. I got to do 9 calculations in the first one, and then add them all together. Okay. Does that make sense? The complement? It's like somebody who's hanging out with kids more recently. People like Lucky Charms when you're young, right? But you don't like the cereal. You like the marshmallows. So if you're pouring yourself a bowl of Lucky Charms and you want just marshmallows, that's the same thing as saying, I want Lucky Charms minus the cereal. And I just want the marshmallows. Same thing. You subtract out the opposite, you get what you want. Lucky Charms minus cereal, all marshmallows.
Lucky Charms sounds good.
No, I love the after cereal.
I really like Lucky Charms.
Made a leprechaun trap and then like a big family box. I was like, oh, these are gonna be good. 8 in the morning.
Okay.
But,
Semi-touch French there, isn't it? Okay. Describe how to figure out the number of ways you can pick a group of 10 students with at most. At most is way different than at least. At most 8 boys means that you could have 0 boys, or 1 boy, or 2 boys, or 3 boys, or 4 boys, or 5, or 6, or 7, or 8 boys. So if you wanted to calculate it one way, you could definitely do all those situations. So you could do calculate 0 to 8 boys. You calculate each one of those and then add them up. So Pardon?
numbers.
Yeah.
I'm adding up the total number of situations. So I would calculate the 0 boys, how many possibilities that happen. Then I'd add the possibility of 1 boy. And I'd add the possibility of 2 boys. And it's going to happen 9 times. It's a lot of calculations. But if you're smart on how you're thinking logically about this, if you want at most 8 boys, then what you don't want is 9 boys or 10 boys. So what you could do is you could just take the total number minus, so I'm actually going to subtract, nine boys or 10 boys. Right? When you're saying at most, you're also saying something else. There's always an opposite to it. So it's like, got a new analogy. People are always going to McDonald's, right? They're like, I want to go to McDonald's, I'm going to get a meal, I really just want the fries. What you're saying is you're going to McDonald's, but you don't want the burger. Right? Compliment. Opposite. Same idea. If you subtract the opposite away from what you could have had, you're left with what you want. Much easier, much more efficient. This is your examples for it, so we'll try some together. A deck of 52 cards. These possibilities are huge. So if you don't use the complement, you're not going to be successful. It's too complex. In a standard deck of 52 cards, how many 5-card hands? How many 5-card hands could you make? If you've ever played poker or something, you get 5 cards in hand, or even something more simple like Uno, something where you get 5 cards. I don't know. You get dealt out your cards. Once they're dealt to you, it didn't matter if you got that king as the first card or the 5th card. All that matters now is you got a king in your hand. So the first thing you ask yourself is, does order matter? Order does not matter. I got 4 aces and a 3. I don't care if it went ace, 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 3, or if it went 3, ace, 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 ace. I got 4 aces and a 3. That's all that matters to me now. The order didn't matter. If the order doesn't matter, then I'm doing a combination. If I want to figure out the total number of possibilities, then I need to go N, C, R. N is the total number of things I'm selecting from. 52 cards. C just stands for combination. R is the number of things I'm selecting. I'm selecting 5 things. This is a huge number. 52, let's see, 5. You can select 2,598,906. That's the total number of card hands you can get dealt. It's a lot of hands. B. How many hands could you make with at least 1 diamond? So that means I could have 1 diamond, or 2 diamonds, or 3 diamonds, or 4 diamonds, or 5 diamonds. There's 13 diamonds in the deck, yeah. Remember, it's 52 divided by 4, because there's 4 suits. So you could do it that way. You could figure out all 5 of those possibilities. That's a lot of calculating. If I want at least 1 diamond, what am I saying? I'm saying I don't want 0 diamonds. So I'm going to take my total possibilities, which was 2,598,960. And I'm going to subtract as if I got no diamonds. So if I get no diamonds, how many cards do I actually get to choose from? it would be 52 minus 13. I'm really only choosing out of the 39 cards. So I'm not allowed to choose one of the diamonds. That's where people get confused. If you have to pick a diamond, n is the number of things you could, or sorry, if you can't pick a diamond, n is the number of things you get to choose from. Diamonds can't be a part of that conversation anymore, because that's not a possibility I'm allowed to give myself. So I had to go 52 minus the 13 diamonds equals there's 39 cards I can actually choose from. So n is 39. Then you go C. How many of those 39 other cards do I want? I want 5. So I want the entire hand to not be diamonds. If you put that in your calculator, 39, choose 5, you get 575,757, and that's a cool number, I'm just going to say. 575757. Cool number. If you go 2598960 minus that number, that means your total possibility of cards with no diamond, or at least one diamond, is 2,023,200. And if you think about it, that's a pretty big number, right? There was 2.5 million cards. Out of those, we're saying 2 million of them include a diamond, which kind of makes sense. There's a good chance one of those 5 will be a diamond. So you're like, yeah, okay, that's reasonable. And that's a pretty big number, but compared to the total number, that's probably a reasonable situation. Ideally, 5 cards, there's a good chance you're getting that diamond. At least one. Any questions about that? That's harder. There's a lot of things going on. Yeah. It works. Any questions about that? Smooth sailing? Use the complement. Total minus what I didn't want.
And if the order doesn't matter, then if it does matter.
If it does matter, we learn that tomorrow. Which is why I keep saying, check to see if it doesn't matter. Right now it seems redundant, but once we start doing orders that do matter, it changes the question. And now every question from tomorrow onwards, you're always going to be asking yourself, does it matter, yes or no? Because it depends what road you go down. Yep. Yeah. Yeah, so if your calculator is NCR and NPR, tomorrow's NPR. Right. Okay, so if you look at C, it says, how many hands could you make with at most 2 kings? This one's kind of tricky. Because what you could do is you could calculate 0 kings, 1 king, and 3 kings. So 3 calculations. Or you could calculate the opposite of at most 2 kings. And the opposite would be if you got 3 kings or 4 kings. So technically, if you do the complement, you save yourself 1 calculation. But reality is, you can do it both ways pretty quickly. We're going to do the complement because I want to practice the complement. Okay? So, the way that this would look, I'm going to take my total possibilities. I'm going to subtract out the complement. The complement would be 3 or 4 kings. So I'm going to do 3 first. How many ways could I do 3 kings? First thing you gotta ask yourself is, how many kings are in the deck that I get to choose from? 4. 4, C, 3. Let's talk about that for a second. That's me saying there's 4 kings in the deck. I want to choose 3 of them. That would only be a 3-card hand. You need a 5-card hand. So you still need to select 2 more cards. So you times. How many cards are there in the deck now that you're allowed to choose from? There was 52 total. but you don't want any more kings. Right? You've already selected your perfect number of 3 kings. So how many cards are not kings? Close. We did 48. Because you don't want to accidentally select that extra king. So what a lot of people would do, and a good multiple choice answer would be 49C2. But that means that that extra king is back in the deck, and you don't want to select it. There's 48 non-kings in the deck. You want to choose 2 of them. Okay, you guys have to stop talking. There's 48 left. You need to choose 2 of them. This is the situation for 3 people. You also need to subtract if you got all 4 kings. So to subtract all 4 kings, there's 4 kings to choose from. You need all 4. There's 48 non-kings to choose from. You need to choose just 1. Make your 5 card. That is all 4 kings. It says at most 2, so we're subtracting the opposite. It's the total minus what you didn't want to have happen. We'll tell you how many you do want to have happen is left. So if you put that in your calculator, you go 4, choose 3, and times it by 48, choose 2. There's 4,512 ways to do that. And if you do the other one, there's 48 ways to do this. If you go that big number, 2598960, and you subtract 4512, subtract 48, your total answer is 2,596,400. That's how many hands would have at most 2 kings. So that's all your hands with 0 kings, which would be a lot. And then all your hands with 1 king, which would also be quite a bit. And then all your hands with 2 kings, all into 1 number. Now,
The 48 is the total kings.
that would be
No,
the total number of ways of getting. Oh yes, that 48. Yeah, that's the total number of cards that aren't kings.
and then the 1, I was doubling the 2.
Because in this hand, I needed a 5-card hand. 3 of them were kings. So 1, 2, 3. There's 2 cards left I still need to pick that aren't kings. That's why I chose 2. In this one, I went 4 and 1 because I went 4 kings, and then I had to pick 1 more card. Because you always have to get to a 5-card hand. You have a bunch of practice, like 2 pages worth. It's not a crazy amount of practice. I suggest that you should be trying to get practice book that's done, like, to the best of your ability. Especially once we get into permutations.